My name's Hazem Gaber. I'm an engineer here, and I'm going to start our HVAC course. You can find more information on our website, HVACengineering.ca. I hope to present at least 5 lessons each week in an easy-to-use format that's practical. And also, I'll be taking any questions you have. Please put your questions in the comments, and we will answer them in the next upcoming slides. So, what is HVAC exactly? It's heating, ventilation, and air conditioning. And this course is going to be based on the ASHRAE 2016 guidelines. Those are the latest guidelines. ASHRAE, of course, is the American Society of Heating, Refrigeration, and Air Conditioning Engineers, and they set guidelines for just that: heating, refrigeration, and air conditioning design, maintenance, and construction. So we see HVAC everywhere. For example, we have these air handling units that are on the roof of a building. They could be made by Carrier, Train, Engineered Air, anybody really. Air handling units are important parts of an HVAC system, as we'll find out later. We also see these things called diffusers. You see them up in the ceiling space all the time, and they're another important part of the ventilation system. They come in all shapes and sizes. So, what does HVAC do? Well, the most important thing is it maintains a desired environmental condition. It makes you feel safe and comfortable. So, people don't really think about HVAC until something goes wrong. So, the temperature is not nice, or humidity is like really musty, or there's toxic gases in your environment. You know, you're at a lab or a furnace or even a restaurant and you have a really bad smell. An HVAC system helps you get rid of that. You don't want to be cold in the winter. That's why you need HVAC. So some of the jobs that HVAC engineers can perform include the conversion of an HVAC system, a building system upgrade, system retrofit, renovation, new construction, and the important parts in any HVAC system design is you need to figure out what are all the components of your system, how they fit and work together, and then ultimately, what is the goal of the system? What is it going to do? Is it going to help people stay warm, stay cold? Is it a safety system? Or is it for comfort? Does it have some other purpose? And, you know, there can be lots of little goals in the system, lots of specifications, you know, temperature range, humidity range, the quality of air. For example, the quality of air at a hospital is going to be much, much higher than the quality of air at a gas station. The velocity requirements, you know, how fast does the air have to move? What the local climate is. You know, an HVAC system in Toronto or Edmonton is much different from an HVAC system in Los Angeles. You also have capacity requirements. A crowded classroom will have a much higher capacity than you know, an empty warehouse. You also have to consider redundancy. Can the customer afford the system to fail? You know, a redundant system is more expensive. You also have to consider security concerns. HVAC at a government building or an arena, it has to be safe so that nobody could introduce toxins into the atmosphere. Then you have to look at costs, right? what does the system cost to install? Uh, what the energy costs? Uh, what are the labor costs for operating the system? Can anybody operate the system, or do you need a highly trained engineer? What are maintenance costs? How reliable is it? How easy is it to control? How loud is it? Is it creating mold or mildew? And of course, these factors, they all affect each other. A system that is very expensive in the short term costs a lot to implement now. It may save you money on maintenance down the road. That's a very important thing to consider. Also, a system that is reliable uh, and redundant may be much larger than a system that is less reliable or has no redundancy. Uh, the other things you can consider when the occupants will move into the building, how much training operators need, does it have to be a germ-free environment, uh, will it help market your rental spaces? An apartment building with an air conditioner is much more attractive than one without one. And of course, it's very important for you as an engineer to engage the owner, the stakeholder. It's very, very important because the owner needs to be involved in the design process. They know what their needs are and what their budget is, and they're going to be owning and using the system for many, many years. The other thing that we always have to look at in any project are constraints. So, in an HVAC system, the main constraints are performance. So, what temperature, humidity, space, and pressure will this system operate under? What are the applicable codes? Do we have ASHRAE? Do we have ASME? Do we have local building codes that we have to follow? What is the available capacity of the system? How much space do we have? What kind of utility source are we going to use? Is it going to be gas? Is it going to be electric? Is it going to be water? What does a building look like? Is there space for our system? That kind of goes in with space, but like, for example, if we're retrofitting a 200-year-old building, that's going to affect the types of components we can install, simply because we want to preserve the historic nature of the building. Other constraints include the conditions of the existing building. What is the capacity of the floor, for example? Do we have large doorways or loading docks that we can bring our equipment into? Do we have to demolish anything? Are we installing a system while there are occupants already in the building? Obviously, what's our budget and schedule? And can we build the system in phases? Um, do we have to order any equipment ahead of time? And how long does it take? If you design a system and say it's only going to take a week to install, but the part that you need is coming from China, and the Chinese manufacturer says, well, I can't ship it to you for a month or 6 months, then you're kind of in a difficult situation, and that's going to affect your schedule. So, of course, there is no substitute for common sense and experience. I can't emphasize that enough. You absolutely need to practice designing and especially installing, because it's easy to draw a system on a piece of paper. It's a lot harder to actually put it together in real life, and real world experience is very, very important. especially in this field. So, the best solution for an HVAC system is to maintain the desired building space environment within an acceptable tolerance under expected conditions and occupant activities. So, we need to define what are expected conditions of our building. What is a typical condition? What is a typical heat load? How many people are expected to occupy the environment? And then we need to figure out what the accepted tolerance is. It might be 2 degrees, it might be 3 degrees. Same with humidity. And of course, the system must physically fit into, on, or adjacent to the building without irritating the occupants. And that doesn't just include the physically fitting, but also noise and vibrations. If the HVAC system keeps people up all night, then you're going to have a serious problem. So you should consider the cooling and humidity control, the ventilation, heat delivery, space, construction cost, the long-term cost, energy, and operability when designing your HVAC system. So don't worry too much. We're going to get into all these details soon. For now, just keep those in mind. So you can come up with a number of different systems in your proposal, and you can come up with a report during your design. This is a sample report. So under categories, we would list uh, each of our criteria for selecting a system. So in this case, they said, well, we need a system that's 78 degrees and the tolerance is, plus or minus 3 degrees when occupied with a 40% relative humidity. Uh, and we're more concerned about how much it costs in the beginning. What's the installation cost? Uh, we put our other important factors, remembering what kind of um, building we have. We have an office building, for example, and there's a number of different tenants, and each tenant needs their own utility metering for billing purposes. We also like to do some things like direct digital control. Uh, we want to follow ASHRAE standard 62.1, and some of our constraints. We can't put any equipment on the first floor, for example. We can't put any equipment on the ground adjacent to the building, so outdoors, for example. So any system that does not meet these constraints, automatically we have to reject. So for every system that we can propose, we can score it under our criteria. So maybe system 1 gets 80, and system 2 gets 60, and system 3 gets 10, or whatever you want to say. And this system gets 30, 20, 5, whatever you think. And so after you've done evaluating each system, and in terms of constraints, they can just be pass or fail. So let's say this system failed, so we're going to forget about system 3. System 3 is terrible. We add up the score, and so let's say we got 100 here. So our first choice obviously will be system 1. Now, obviously, your evaluation could be much longer and much different, and we haven't learned exactly what all these factors are. So we're going to look at them in more detail in the coming weeks. So it's important to set up a final report, and the final report details your design. And what you should include are the originally established goals, what criteria you selected, what are the important factors of your system, including advantages and disadvantages, how well the system integrates with other systems, other goals, security, how the system affects the building envelope, what the project timeline would look like, including design, equipment delivery, considering that some manufacturers take longer than others, commissioning, training, and construction. We want to also look at budget costs. What's the system going to cost at first? What's it going to cost to operate? That includes maintenance and what the energy cost will be. And of course, our final recommendation: which system should the owner choose?